Hello everyone, my name is Alakh Verma and I'm a student of Engineering Physics third year. My enrollment number is 1911106 and today I'll be presenting how to reverse an 8-bit number using 8085 microprocessor program. So first let's talk about the overview of the presentation. We'll be discussing the problem statement, then we'll go through the algorithm. Then I'll be discussing about the program written in 8085 microprocessor simulator, and then I'll show you the demo of the program. So first let's talk about the problem statement. The problem statement is to reverse 8-bit number using 8085 microprocessor. For example, we take 98 as the input. Here 98 is in hex and it is stored in the memory location 2050. The output we get is 89 and it's stored in the memory location 3050. Here we are assuming that the number to be reversed is stored at memory location 2050 and the reverse number is stored at the memory location 3050 as shown in the figure. So now let's talk about the algorithm. First, we'll load the content of memory location 2050 into the accumulator A. Then we'll use RLC instruction, about which we'll talk in the next slide. In order to shift the content of A by 1 bit without carry, we'll use the same instruction RLC 4 times in order to reverse the content of A. And then we'll later store the content of A in memory location 3050. Here, RLC stands for rotate left accumulator. It rotates the accumulator contents to the left by 1 bit position. So the most significant bit of the accumulator will come out and left rotate will create an empty space at the least significant bit place, and this come out bit will be copied at the empty bit place and also on the carry bit in the flag register. Thus carry flag gets a copy of the bit moved out from the most significant bit position. And one thing to note is that carry flag is not involved in the rotation. It is only 8-bit rotation of the accumulator contents. Only carry flag is affected by this instruction execution. So this is the flowchart of the program. We'll start by loading in the content in the accumulator. Then we'll rotate the accumulator content by 1 bit to the left. We'll repeat the same instruction 4 times. And then we'll store the content of A at the memory location 3050, and then we'll terminate the program. So here we are first updating the memory location 2050 by feeding in the data 98. So this 98 will get converted to hex at the start of the program to 62. So as you can see, 98 is converted to 62 when we from decimal to hex, 98 becomes 62. So the program goes like this: LDA 2050. This will load the value of memory location 2050 into the accumulator A. RLC, this will rotate the content of the accumulator to the left by 1 bit. We are using this instruction 4 times. So we'll rotate the content of the accumulator by 4 times, each 1 bit each time. Then we'll store the content of the accumulator in memory location 3050, and then we'll stop the program. So it'll start it by halting any further execution. So the result, if we check the address 3050, it says that the data here is 38. Now, if we convert this to hex, we get 26. So 26 is the reverse of 62, and hence we have reversed the 8-bit numbers 98, which when converted to hex becomes 62, and on reversing becomes 26. So this is the demo. So here, as you can see, we are first going to update the memory location 2050. We're storing 98. So here it gets updated. Then we are going to assemble the program. After assembling, we are going to execute. It becomes 62, which is the hex of 98. So we'll read each and every instruction. And at the end of the program, if we type 3050, 3050 is the new address where the reverse bit 8-bit number is stored. Here it shows 38. Now, if we convert 38 to hex, we get 26. So 26 is the reverse of 62, and hence we have reversed. Yes, this is the reverse of 62, and hence we have reversed the 8-bit number 62. Thank you.